Hi, it's Moser with some hints and tips on the 4B problems. This is number 7 from the 4B worksheet that's associated with your Holt physics textbook. So we have a big toad, and we have this weird little toad elevator that someone made. The toad is being pulled upwards so that it's got a net acceleration of 2.55 meters per second, and we want to know the force of tension in the cables. So I'm going to start off by dividing those forces of tension into a force of tension y and a force of tension x, and that's just sort of a mental trick for myself so that I can see that that force of tension, because it's not directly on either axis, will have to be dealt with into component vectors. And I'm going to go ahead and just do my little thing on the x-axis so that I prove to myself in essence that those forces of tension are equal. So, okay, great. Well, now I'm going to draw a free body diagram, because the forces acting on the tension are the same as if they were coming out of the center of the object, despite the fact that they're not, despite the fact that there's that whole little joining the cables together and splitting them apart to make the elevator thing. They behave as if they were coming directly from the center of mass. So I'm going to do a sum of forces on the y, and as always it's equal to all the forces up minus all the forces down. We've got a force of tension y1, force of tension y2, minus the force of gravity, but the sum of forces on the y is also equal to ma. So now you would be able to set those equal to one another, and now as long as you know how to correctly find the component vector that represents the force of tension on the y-axis, I think you can probably take it from there using some of the same strategies you've used before.